A few emails regarding question 3.61, a combustion analysis, a 0.44 gram sample of an unknown yields 0.88 grams of CO2, 0.36 grams of water. The molar mass is 132. What's the molecular formula, carbon, hydrogen, oxygen of that sample? A little bit different than the problems we did in class in that they give you the mass of CO2, they give you the mass of water. We're going to have to work backwards to find what's the mass of hydrogen in the sample, what's the mass of carbon in the sample, and those are the problems I gave you in class. So I already gave you that information teased out. And then this is a little bit even trickier in that once we find the mass of carbon and hydrogen, well, we also have to find the mass of oxygen in this sample, so we'll have to subtract those masses from the original 0.44 grams to find the mass of carbon. So the first step, we need to find how many moles of CO2, how many moles of water we have in the sample. So moles of CO2 equals, moles equals grams over, the molar mass. CO2 is 44 grams per mole. Moles of water, 0.36 grams divided by the molar mass of water, 18 grams per mole. So we have 0.02 moles of CO2, 0.02 moles of water, and next, I need to find out, okay, how many moles of carbon do I have? Well, in 1 mole of CO2, I have 1 mole of carbon, I have 1 carbon atom per each 1 carbon dioxide. So in 1 mole of water, H2O, I'm going to have 2 moles of hydrogen, because for every 1 water, there are 2 hydrogens in that sample. So moles of carbon dioxide cancel, moles of water cancel. I'm going to have 0.02 moles of carbon, and I'm going to have 0.04 moles of hydrogen. But I need to know how much that weighs, right? So I want to use this mole of carbon, this mole of hydrogen to find out what is the mass of carbon I should have and what's the mass of hydrogen I should have. So I want to go again to the periodic table, and I'll see, okay, for every 1 mole of carbon, carbon is 12 AMU, so I would need 12 grams, of carbon to have 1 mole. And for every mole of hydrogen, hydrogen is 1 AMU, so I would need 1 gram of hydrogen. So for the mass, just multiply across, moles of carbon will cancel out. I'll have 0.24 moles, or 0.24 grams, carbon, and I would have 0.04 grams of hydrogen in this sample. So now I can take these masses, 0.04 grams of hydrogen, 0.24 grams of carbon, with the original mass of the sample to find out what's the remaining mass, and that's the mass of oxygen that I want to look for. But don't forget about these molar numbers, because once I find the mass of oxygen, then I can find moles of oxygen, and then I'm going to find a molar ratio using that. So the whole sample is 0.44 grams. I've got 0.24 grams of carbon that I'm subtracting, and I've got 0.04 grams of hydrogen that I'm subtracting from that sample. And I apologize, I'm not sure why there's such a large lag in the pen today. But I'll subtract all of those amounts to see that basically I've got 0.16 grams remaining, and that should be the mass of oxygen. So now I need to find moles of oxygen, and so I've got 0.16 grams of oxygen. The molar mass of oxygen, 16 AMU, so 16 grams per mole. So I have 0.01 moles of oxygen, and I'll wait for that to catch up here because I'm a little bit ahead. But now that I have moles of oxygen, now I'm going to go back to these molar amounts of carbon and hydrogen because I need to find a molar ratio. So now this should be comfortable for you because we did this a couple times in class. To find that molar ratio, we wanted to divide everything by the smallest number of moles. So I've got 0.04 moles of hydrogen, 0.02 moles of carbon. I'm going to divide everything by the moles of oxygen. So I divide everything by the smallest number of moles, the moles of oxygen, which is 0.01, to see, okay, that gives me a molar ratio of 1 mole of oxygen to 2 moles of carbon to 4 moles of hydrogen. That is my empirical formula, C2H4O1. And now, to go from my empirical formula to my total molecular formula for everything in the molecule, I need to find the empirical weight. And so for that, I'll see I have 2 carbons at 12 AMU each, 4 hydrogens at 1 AMU each, and then 1 oxygen at 16 AMU. So 24 plus 4 plus 16. My empirical formula is 44 grams per mole for the empirical formula here. So to find what do I need to multiply this by to get my molecular formula, I simply find what's the ratio between my molecular weight, 132, over my empirical formula weight, 44 grams per mole. So 132 divided by 44 should give me a factor of 3. So 132, that's my total molar mass divided by my empirical weight of 44. That goes in there 3 times. So to find the total molecular formula, I would take the empirical formula, multiply it by 3 to come up with the full molecular formula of C6H12O3. And that should be the final answer that they're looking for this problem. So yes, it's a little bit more involved than the problems that we did in class, but once we found the moles, right, that second half of this should have been pretty comfortable for you to find the molar ratio. And then once we found the molar ratio, we found the empirical formula. Once we found the empirical formula, we could find the empirical weight as 44, and then use that to find what's the ratio between my empirical formula and my molecular formula. Well, a factor of 3. So I needed to multiply everything by 3 to come up with the molecular formula of C6H12O3. So hopefully that helps.